Okay, so for the first question here, we're told that we have aluminum sulfide, which is Al2S3, reacting with magnesium chloride, which is MgCl2, and it's a double displacement reaction. So our metals can swap spots, and we would end up with MgS and AlCl3. From there, of course, we need to balance this. So I'm going to put a 2 in front of my aluminum chloride. I'm going to put a 3 in front of my magnesium sulfide, which means that I need to put a 3 in front of my magnesium chloride. Now I have 2 aluminums on each side, 3 sulfur on each side, 3 magnesium, and 3 times 2 is 6 chlorine. I'm also told that I have 23 grams of aluminum sulfide and 24 grams of magnesium chloride. So the first thing that I'm going to do after balancing my chemical equation is figure out what my molar masses of those two reactants are. So if I go over to my periodic table, I can calculate those. So aluminum is 26.58, I'll times that by 2, and then I will add 3 times 32 for the sulfur and get 149.16. For the magnesium, I'll take my magnesium, which is 24.3, and add 2 times 35.45 for the chlorine and get 95.2. My second step is going to be to do moles equals mass over molar mass for both reactants. So I'll have 23 over 149.16. I'll also have 24 over 95.2. That gives me 0.1542 moles of the aluminum sulfide. And it's important to note that these are the actual moles that are present. And then for the magnesium chloride, 24 divided by 95.2 is 0.2521 moles of magnesium chloride actual. Again, it's really important that you're labeling what these moles are because we're about to have a bunch of different mole numbers. The next step is to set up a mole ratio between our two reactants. So aluminum sulfide to magnesium chloride. This is a 1:3 ratio. And then all I'm going to do is I'm going to pick either of these two mole amounts. It doesn't matter which one I pick, which actual mole amount I pick. In the end, you'll be able to solve either way. So I'm going to plug in my 0.1542 moles. That means I put an X where the other one is. If you put in the 0.2521 mole for magnesium chloride, you would put your X here. It doesn't matter which one you do. I'm going to cross multiply, which leaves me with X equals 0.1542 times 3, which is 0.4626 moles. Now, because the X was under this side, that means I just solved for the moles of magnesium chloride. And when I do the mole ratio, I'm not getting the actual amount of moles. I'm getting the amount of moles that I would need if I wanted to use up all of the magnesium chloride. Okay. So my last step then is to just compare the amount of moles needed to the actual amount of moles. Right now, I need more than I actually have. I need 0.46, I have 0.25. So because I need more than I have of the magnesium chloride, means I don't have enough. Therefore, magnesium chloride is limiting, which also means that my aluminum sulfide is the excess reagent. Okay. Now, just to show you what it would look like if you had set up your mole ratio the other way. Again, it would still be a 1:3 ratio, but if I had put the X under aluminum sulfide and plugged in the actual moles of magnesium chloride, I would have had 3x equals 0.2521, divide by 3. 0.2521 divided by 3 is 0.084 moles of aluminum sulfide needed. Now, as you can see, if that were the case, I have 0.15. If I only need 0.08, I have more than I need. If you have more than you need of your aluminum sulfide, that means that the aluminum sulfide is in excess. And as soon as I find out what my excess reagent is, that means the other reagent is limiting. So either way, regardless of which mole ratio you did as your third step, you still would have got that magnesium chloride is limiting. Okay. What I would like you guys to try now are the finding the limiting reagent questions on this slide here. Okay, guys, just really quickly here, this is supposed to, the second number 1 here is supposed to be a single replacement reaction, but we don't do single replacement reactions between molecular compounds. So just skip this second one here and just do the first and last one. Okay, that's all. Okay, so for the first question here, we've got our lead 2 nitrate and our sodium sulfate reacting in a double displacement reaction, and then we balance it with a 2. Then I find my molar mass of both reactants. So this is 331.2 and 142. Then I do moles equals mass over molar mass, moles equals mass over molar mass, to find the actual moles of both reactants. You should get 0.0453 moles of the lead nitrate and 0.0845 moles of the sodium sulfate. Then we set up a mole ratio between our 2 reactants. It is a 1-to-1 ratio in this case. So when we plug in our X and one of our mole values, you will get 0.0453 moles of sodium sulfate needed. Or again, you could have put the X in the first position here and plugged in 0.0845 moles in the other position. You would have got 0.0845 moles of lead nitrate needed. If you did it like I did here, you'll see that you only need 0.04 moles of the sodium sulfate and you have 0.08. So you have more than you need, which means the sodium sulfate is in excess, which means the lead nitrate is limiting. If you had plugged in the X in the other position, you would have got 0.0845 moles of the lead nitrate, which means that you would have needed more than you have. again, that would have led you to the conclusion that the lead nitrate is limiting. Again, I said skip the second question there. It's just not a good question. The third question is a reaction between solid potassium and some fluorine gas. Don't forget, fluorine is diatomic. And then this would create potassium fluoride. We find our molar mass of potassium, which is 39, and the fluorine gas is 38. Then we do moles equals mass over molar mass for both of our reactants. You should get 0.1795 moles of potassium that you actually have, and 0.1316 moles of the fluorine that you actually have. Then you set up a mole ratio between the two reactants. It is a 2-to-1 ratio this time. Plug in the X on either side in the bottom, plug in the moles on the other side, and then cross multiply. If you did it the way I did, you would get 0.2632 moles of potassium needed. Then we say, okay, we need 0.26 moles. We only have about 0.18, so we have less than we need. Therefore, the potassium is limiting. Again, if you had done it the other way around, you would have found out that you have more fluorine than you need, and therefore it's an excess, which means the potassium is limiting. Okay, so that is how you figure out what your limiting or excess reagent is. The next thing is figuring out how much of a product has been produced. And again, we do that based on our limiting reagent. So your first step when determining the amount of product is to, of course, write and balance your chemical equation. And then if you're not given, if you're not told what the limiting reagent is, you're going to have to follow the steps that we just did, where you find the amount of moles of each of your reagents, use the mole ratio to figure out which of your reagents is limiting. Once you know which of your reagents is limiting, you use the actual moles of the limiting reagents and then plug that into a mole ratio to figure out the moles of the product, and then convert the moles of the product into mass using moles equals mass over molar mass. So this is an example that you can read through if you would like, but I'm going to flip to this slide here. We're going to do example 2, or I'm going to do example 2 with you guys to kind of show you how it's done, and then you guys can try number 1 and number 3 on your own. Okay, so question number 2 says, in a reaction between 7 grams of solid potassium and 5 grams of fluorine gas, determine the mass of the product. Use the information that we calculated on question number 3, slide 9. So that is this calculation that we just went over, where we had the potassium, the fluorine making the potassium fluoride. So when you're doing these questions, when you're not told which reactant is limiting, you just follow these exact steps. Part 1 of determining the amount of products is to identify your limiting reagent. Once you have your limiting reagent, then you take the actual moles of that limiting reagent and plug it into a mole ratio between that reagent and your product. So what I'm going to do here now is I'm going to take I'm going to set up my mole ratio, sorry, between my potassium, because that is my limiting reagent, and my product, which is my potassium fluoride. This is a 2-to-2 ratio, which you could simplify to a 1-to-1 ratio if you wanted. And then I'm going to plug in, again, the actual moles of potassium, not the moles of potassium that I need, the actual moles of potassium. So 0.1795 and X, and then we cross multiply to get 0.359, and then we divide. And of course get 1.795 moles of our product. What I'm then going to do is I'm going to go back to my equation here that I started off with, my balanced chemical equation. I'm going to figure out what the molar mass of my product is. So that'll be 19 plus 39 is 58. And then, so that was step 5. And then step 6 is just plug in the moles that I just calculated and the molar mass into my moles equals mass over molar mass formula. Of course, I multiply by 58. And I will get 10.41 grams of my product. Okay, so try questions 1 and number 3 on that slide and come back for the answers. Okay, so for question number 1, you have potassium tribromide reacting with an excess of nitrogen gas, which is diatomic, to make bromine, which is also diatomic, and then a byproduct. And the reason I know the byproduct is PN is because if I were to, oopsies, draw this out, they each have 3 bonding sites, which means it would just be a P triple bonded to an N. Okay. Don't worry if you had trouble figuring out what that byproduct is. On a test or quiz, all of these like reactions that you have to write yourself will either be like between a ionic compound and another molecule, or between 2 ionic compounds, or it'll be like a combustion reaction, or it'll tell you what the products are. So you'll never on a test or quiz have 2 molecular reactants and have to figure out what the products are, what the 2 different products are. Okay, just so you know. Anyway, in this case, it told us that the nitrogen gas was in excess. So we can pretty much just ignore this nitrogen gas because we know that the other reagent must be the limiting one, and it is the limiting reagent that we have to use in our mole ratio to find how many grams of our bromine there are. So I figured out what the molar mass is of my reactant, also what the molar mass is of my product. Then I did the mole ratio to figure out how many moles of phosphorus tribromide I had, and you should get 0.0482 moles. I then set up a mole ratio between my limiting reagent and my product. It's a 2:3 ratio. I plug in the actual moles of my product, cross multiply and divide to get 0.2895 moles of the bromine, and then I just plug that into my moles equals mass over molar mass to solve, and I get 46 grams of the bromine. Okay, so for the last question here, we have lithium, 8 grams of it, reacting with 6 grams of oxygen, which, don't forget, is diatomic. And this is a synthesis reaction, so we're going to be making lithium oxide, and then of course we cross our charges, which is why we have Li2O. Then of course we balance it, we figure out the molar mass of both of our reagents and our product. Since this time we weren't told which of our reagents is limiting. So that's what the first part of this question is going to be, is just figuring out which of our reagents is limiting. So I start by doing moles equals mass over molar mass for both of my reagents. You should get 1.153 moles of lithium that you actually have, and 0.1875 moles of oxygen that you actually have. Then you're going to set up a mole ratio between your 2 reagents. It is a 4:1 ratio. We plug in an X on either side. In the bottom, plug in our actual moles for one of our reactants, and then cross multiply. If you did it the way I did, you would get 0.75 moles of lithium that you need. And as you can see, you have way more than you need. You have over 1 moles, you only need 0.75. That means that the lithium is in excess, which means that the oxygen is limiting. If you had put the X on the other side and 1.153 here and cross multiplied, you would have gotten that you needed more oxygen than you actually had. And once again, that would tell you oxygen is limiting. Once you figure out that the oxygen is limiting, you can then move on to steps 5 and 6, which are like kind of the part 2 of this question. You're going to set up a mole ratio between your limiting reagent and the product. So in this case, the oxygen and the lithium oxide. According to our balanced chemical equation, it is a 1:2 ratio. So a 1:2 ratio. We plug in the actual moles of oxygen and cross multiply, and that gives you 0.375 moles of our lithium oxide. We then plug that into our moles equals mass over molar mass, and you should get about 14.6 grams of the lithium oxide. Okay, so I'm going to end there for today. Again, like I said, this is a long lesson and there's lots of different practice questions and stuff for you guys to do. Tomorrow we'll be continuing on with this same PowerPoint, but we're going to be looking at the excess reagent more so than the limiting reagent stuff that we were doing today. So I'll see you there.